everyone, this is a tutorial on how to do conversions. So first thing is you've got to be familiar with the different symbols and conversion factors within the metric system. The prefixes are all based on how many powers of 10 away is your number from base units. So a megajoule of energy, which is commonly used as like calories or measure of food caloric intake, a megajoule of energy is 10 to the sixth, or, about a million joules. So, how we would use a conversion factor is to take a single number like 62 kilograms and replace the K with its conversion factor from up above. So the number 62 stays the same, but I want to replace the K with the factor in the table. So the K gets replaced by 10 to the third. So it's 62 times 10 to the third grams. Now you can use that number as is, or you could evaluate this in your calculator. 62 kilograms is then 62,000 grams. Let's do it again with centimeters. So the number 30 is going to stay the same, but I'm replacing the C with its conversion factor from the table. A centimeter is 10 to the negative 2, so that's 30 times 10 to the negative 2 meters. Evaluating this in your calculator is 0.30 meters. And this makes sense to me because if I picture a whole meter stick, 30 centimeters is about a third of a meter, right? So that makes sense to me. In physics, nanometers are commonly used when we're talking about things on the microscopic scale, like the size of certain molecules. In this case, 410 nanometers is the wavelength of violet light. So 410 stays the same. Nano is getting replaced by 10 to the negative ninth, and meters stays the same. So evaluating this, you can see why I would not want to write out nanometers in regular units. 410 nanometers is 0.000000410 meters. We commonly use nanometers to measure wavelengths of light because when I use nanometers, at least that's a number that I don't have to keep track of many zeros for. So the wavelength for red is 650 nanometers, and that follows to me. So last one, 32 megabytes. And you might have seen this when you're doing download speeds. It might say something like megabytes per second. This is from like a data sciences, computers perspective. So the 32 stays the same. I'm going to replace M with mega. Mega's conversion factor is 10 to the sixth. So 32 times 10 to the sixth, and bytes stays the same. So this data is 32 million. So to recap, if you just need to convert one number to another and you just need to get it into base units, you're still writing the original digit. So let's highlight that in yellow. The original number is 62. Grams is going to stay the same, still 62 in grams. And the only thing I'm converting is K. K gets replaced with 10 to the third, its conversion factor from above. Now, I do have to point something out. If you're using this for chemistry versus physics, the base units actually change. A chemist is normally dealing with significantly smaller quantities of mass, and on a much smaller scale. So chemistry uses centimeters as the base unit for length, grams is the base unit for mass, and of course seconds for time. These are the most important because chemistry is going to be dealing with things on a smaller scale than physics. So if I was given a distance in meters, I'd have to convert it to centimeters. If it was a problem given in kilograms of mass, I'd have to convert it in grams to use any of the chemistry equations. Similarly, in physics, if I'm given something in centimeters of length, I need to convert that to meters. Physics deals with much bigger quantities, like the mass of a car, I would measure in kilograms. That's interesting then, because if I were given this example problem of 62 kilograms, I actually don't need to convert with physics. And of course, time stays in seconds. So, assuming we're in physics class right now, let's pretend we're in physics and let's do some problems. These are all problems that have conversions built into them. So, let's say I'm calculating the weight of a 30-gram car. I'm going to look up the weight equation on my equation sheet, and my 300 grams needs to get converted to kilograms before I can use this equation. So 300 grams is not in the base unit of kilograms, and I need to figure out how many kilograms this is. So I'm still going to use my conversion factor, but notice this time I have to divide by 10 to the third. The correct number of kilograms is 300 grams divided by 10 to the third. So this is 0.300 kilograms. A good check at the beginning of a problem is to convert first into base units. So I needed to convert to kilograms because in physics, mass is in kilograms. That's 0.300 kilograms times 9.8 newtons per kilogram, or 2.96 newtons. With the electron drift velocity, I need to convert into meters per second before I can continue. So I'm just going to change my 9 centimeters to meters. This is just a regular conversion because centi is getting us to the base unit. So it's 9 times 10 to the negative 2, or 0.09 meters. So I have my speed on the left, calculating for distance on the right, in 30 seconds. Multiplying 30 on both sides, the distance is 30 times 0.09, or 2.7 meters. We're calculating the frequency of violet light, whose wavelength is 410 nanometers. Got to convert it to meters, so that's 410. Putting in our conversion factor of 10 to the negative 9th. We had done this problem earlier, so that's our 6 zeros here. Finally, to calculate the frequency of light, I'm using our wave speed equation. The speed of light is 3 times 10 to the 8th meters per second. The wavelength is 0.00004. Can you see how I might want to just leave this in scientific notation and not even bother converting it? Because now dividing by big number on both sides, our frequency is 3 times 10 to the 8th over 410 nanometers. And that gives us a frequency of 7.31 times 10 to the 14th. So let's recap from the beginning. If you just want to convert a single number, I'm going to take that number, like 410, in the base units of meters, and make it stay still, keep it the same. But I'm going to replace this nano here. It gets replaced by 10 to the negative 9th. So now I've converted 410 nanometers to meters. When you go through a problem, make sure you're using the physics base units. So if I see something in grams, I need to convert to kilograms. If it's in centimeters, I need to convert to meters. If it's in hours, I need to convert to seconds. So for whatever problems you're doing, it's a good first step to go through and see if anything needs converting. Once you've completed the conversion, then you're solving the physics equation. So you'd pick out the equation for 1 point, substitution for 1 point, solution for 1 point, with a point for conversions if it applies in that problem. All right, everyone, best of luck.